This is MA 104, Section 3.6. For number 31, we're asked to determine if g is the inverse of f. We could do this by calculating the inverse of the function f and then just seeing if it compares to the function g. Or we could use that property of functional composition with inverses that says that if I take the composition f composed with g of x, if the two functions are inverses, then that composition should equal x. Likewise, if I take the composition g composed with f of x, if the functions are inverses, then that composition should equal x. So I can evaluate both of these compositions and make sure that they equal x. That's enough to verify that the two functions are inverses. So for the first composition, f composed with g of x, that means finding f of g of x. In other words, I want to evaluate the function f, and for the domain value, I want to actually plug in the entire function g of x, which is 1/3 x minus 5/3. Coming back to my function f, instead of taking 3 times x plus 5, I'll take 3 times 1/3 x minus 5/3 plus 5. In other words, where I saw the domain value x, I'll fill in the function g. So that gives me 3 times the quantity 1/3 x minus 5/3, and I still have the plus 5. Distributing the 3 times 1/3 x is just x. 3 times minus 5/3 is minus 5. I still have the plus 5. The whole thing simplifies to x, which does indicate that I'm halfway there to proving that these functions are inverses. For the composition g composed with f of x, that means taking the function g and evaluating it at the function f of x. So I'll take that function g, and wherever I see the domain value, I'll plug in the function f of x, which is 3x plus 5. So I'll take that function g of x, and instead of writing 1/3 times x, I'll write 1/3 times 3x plus 5 minus the 5/3. So that gives me 1/3 times that quantity, 3x plus 5 minus 5/3. Distributing the 1/3, 1/3 times 3x is just x. 1/3 times 5 is plus 5/3. I still have the minus 5/3. The plus 5/3 minus 5/3 cancels each other out, and I am left with x. Since in both directions those compositions equal x, that means that yes, the functions are inverses of one another. Again, to determine if g is the inverse of f, I can use the idea of functional composition. I will evaluate f composed with g of x. If these functions are inverses, that composition should equal x. And likewise, the composition g composed with f of x, if these functions are inverses, that should equal x. The functional composition f composed with g of x just means finding f of g of x. So I will be evaluating the function f at the function g of x, and g of x is just the square root of x minus 4. So this means finding f of the square root of x minus 4. So back to my function f, wherever I see an x, I'll plug in that square root of x minus 4. So I have 4 plus the quantity, the square root of x minus 4 squared, which gives me 4 plus the radical and the exponent cancel out, so that leaves me with x minus 4. My 4's cancel, and I do have x. So the composition f composed with g of x does equal x. To find the composition g composed with f of x, that means finding g of f of x. So I want to evaluate the function g at the function f of x, which is the quantity 4 plus x squared. So if I come to the function g, which is the square root of x minus 4, now I'll be evaluating the square root of 4 plus x squared minus 4, which leaves me with the square root of x squared, which, because my domain values are positive, I know is just equal to x. So again, the composition in both directions is equal to x, which means that yes, these functions are inverses of one another. For 41, we're asked to do several things. We have to find the domain and the range of the function f, which is graphed. We have to sketch the graph of the inverse and find the domain and range of the inverse. Well, if I start by examining my function f starts at this point, which is negative 4, 1, and it ends at this point, which is 4, 5. So rather quickly I can tell that the domain of my function f is just the span of the x-coordinates. In other words, from here to here, I have every point included between negative 4 and positive 4. So my domain goes from negative 4 to positive 4. The range of f is just the span of the y-coordinates. Again, if it starts at this point and goes up to this point, the range values are 1 and 5. So the range of my function goes from 1 to 5. Without even sketching the graph of the inverse or calculating the graph of the inverse, I can very quickly tell that the domain of the inverse and the range of the inverse by using the idea that the domain of the inverse is just going to equal the range of the original. So, I'm sorry, I circled the wrong one there. So the domain of the inverse is just equal to the range of the original. So the domain of my inverse will be the span from 1 to 5. And the range of my inverse is just the domain of the original. So the range of my inverse is going to be the interval from negative 4 to positive 4. The domain and the range are just switched to calculate the inverse function. When I go to sketch this, I can use another idea that if the point negative 4, 1 is a point on my original function, then the point 1, negative 4 will be a point on my inverse. By the same token, if the point 4, 5 is a point on my original function, then the point 5, 4 will be on my inverse. I can also use the idea of symmetry. I know that this line y equals x acts as a line of symmetry for a function in its inverse. So if I sort of use that idea, I can connect those 2 points to get a fairly decent sketch of my inverse function. Same idea for this. I need to find the domain and the range of my function f. To start there, I'll label the starting and ending points. This function starts at this point, ends at this point. So this point is negative 5, negative 3, and this top point is 3, 5. That will very quickly tell me the domain of my function f and the range of my function f. The domain starts at negative 5 and goes to positive 3, so that is going to go from negative 5 to 3. The range includes the y-coordinates, which go from negative 3 to positive 5, so the range here will be from negative 3 to 5. The domain and range of my inverse I can quickly calculate. The domain of my inverse is simply the range of my original. So the domain of the inverse is going to go from negative 3 to positive 5. The range of my inverse is going to equal the domain of the original. So the range of the inverse simply goes from negative 5 to positive 3. Again, I can use the idea that if the point negative 5, negative 3 is a point on my original function, then the point negative 3, negative 5 will be on the inverse. I just switch the domain and the range values. If the point 3, 5 is a point on my original function, then the point 5, 3 will be on the inverse. I can use the idea of symmetry to sketch the inverse function using that line y equals x as an axis of symmetry.